Okay, so we're going to do a couple problems with trig in the chain rule. So the first one you can see is 5 over the secant of x squared. I'm going to go ahead and do the quotient rule on this one because it looks like a quotient. You may disagree with me, and that's good because that's not really how I would do this problem, but we're going to do it anyhow because it looks like a quotient. So we have the bottom times the derivative of the top, which is 0, minus the top times the derivative of the bottom. This is where the chain rule is going to come in. Think of this as the secant of the quantity x squared. So secant's your outside function. The derivative of secant is secant, leave the inside alone, tangent, times the derivative of the inside, which is 2x, all over the bottom squared. So secant squared x squared. So now we're going to simplify. This is 0. We have negative 5 times 2x is 10x. So we have negative 10x secant x squared tangent x squared over secant squared x squared. These are all factors, so I can cancel one of these secant x squareds with one of these secant x squareds. You're left with negative 10 tangent x squared over secant x squared. Now, hopefully, when I started this and I said quotient rule, you said, whoa, why don't we make it a product rule or just a chain rule? You can always change trig functions to sines and cosines, and this, since secant is a reciprocal of cosine, it looks to be a much easier problem to do it like this. It's not really a product because 5 is a constant multiple. It is a chain because it's the cosine of x squared. So we should be able to do this one pretty quickly. The derivative of cosine is negative sine. Leave the inside alone. Times derivative of the inside, which is 2x. Multiply everything together, we have negative 10x sine of x squared. So that's our answer. This must be the same as this. I forgot my equal sign here. Well, just to verify that, tan is sine over cosine. So this is sine x squared over cosine x squared. Secant is 1 over cosine, so this would be cosine squared up top. You can cancel those and you get negative 10 sine x squared. And you can see from Wolfram alpha, which I did include somewhere here. I can't find it now. Hold on. We got negative 10x sine x squared. So that looks good. Let's do the other one. That won't take too long. The other one I have is, this is the one that gives most people trouble. Now, you could actually change this into cotangent x squared plus 7 times cotangent x squared plus 7 times cotangent x squared plus 7 and use the product rule, the extended product rule. But it's easier to think of this how you should think of it, as this. So we have a few things going on here. The outside function is the cube function. Then we have a inner function which is cotangent, but cotangent itself has an inside function. So the most outside function is cubed. The cotangent comes second, and the inside function is x squared plus 7. So this is where I really love symbolic differentiation, because the problem people have with problems like this is they do too much at once. Symbolic differentiation helps that. So the derivative is the derivative of the outside. Leave the inside alone. Times now the derivative of the inside, which I'm not going to do. I'm just going to write it symbolically. What that does is allows me to now focus on this. So I'm not doing too much at once. So I'm kind of ignoring the other half for now and thinking, well, what's the derivative cotangent of x squared plus 7? Well, you start all over again. X squared plus 7 is inside the cotangent. So cotangent is the outside function. Therefore, the derivative of cotangent, which you do first, is negative cosecant squared. Leave the inside alone. And then times the derivative of the inside. I'm going to keep my symbolic. You can just write x squared, or 2x, obviously, but since I started symbolically, I'm going to go with it. Now you can see the only thing I have left to do is take the derivative of this x squared. So I have negative cosecant squared x squared plus 7 times 2x. Now don't forget, we have this too. So 3, I can write this as cotangent squared of x squared plus 7 times all of this. Now it's all one factor. So let's multiply all the constants together. The 3, the negative, and the 2x to get negative 6x. You can see we have cotangent squared of x squared plus 7 and cosecant squared of x squared plus 7. So the only thing I would think about here is cotangent is cosine over sine. Cosecant is 1 over sine. So you're not really going to get any cancellations. So I'm pretty satisfied with this answer right here. I'm going to go to Wolfram Alpha just to see what they think. They think it's negative 6x cotangent squared x squared plus 7 cosecant squared x squared plus 7. Well, that's what we thought. So there you go. That's the answer to this one. Again, if you change it to sines and cosines, which you can, you would have gotten negative 6x cosine squared x squared plus 7 over sine to the 4th x squared plus 7. That doesn't really simplify things. So that's it for the trig. Make sure you practice what you need to.